Hello students, in this video we learn about numerical integration. Numerical integration means the process of evaluating a definite integral from a set of tabulated values of the integrand function f of x equal to y is called numerical integration. For a given integral I equal to integral from a to b f of x dx or I equal to integral from a to b y dx, first we divide the interval ab into n equal subintervals such that a equal to x naught, which will be less than x1, which will be less than x2, x2 is less than x3. It continues till less than xn, which is b, with step length h equal to b minus a by n. Now, xn is given by x naught plus nh. Now, if I want to find x1, then my formula will be x1 equal to, if you put here n equal to 1, x1 will be x naught plus h. Similarly, if I want to find the value of say x2, then x2 will be x naught plus 2h, or the alternate method is I can write x2 is equal to x1 plus h. Similarly, x3 we can write it as x naught plus 3h, or x3 is equal to x2 plus h. Now, numerical integration of a single valued function is called as quadrature. The following are the some of the methods for quadrature. Mainly there are three methods. The first one is Simpson's 1/3 rule. The second one is Simpson's 3 by 8th rule or 3/8 rule. And third one is Weddell's rule. Now, first we will see what is Simpson's 1/3 rule. Let I equal to integral from a to b f of x dx be the given integral to be evaluated. To use Simpson's 1/3 rule for evaluation of the value of I, the interval a b of integration must be divided into n number of subintervals where n should be a multiple of 2. Dear students, you have to remember one thing. To use Simpson's 1/3 rule, n should be a multiple of 2. This is very important. And Simpson's 1/3 rule is given by I equal to h by 3 multiplied by y naught plus yn. That is, y naught is first value of y and yn is last value of y, plus 4 times the odd values, that is y1 plus y3 plus y5, etc. It continues till plus yn minus 1, plus 2 times even values, even number of values, y2 plus y4 plus y6, etc. up to yn minus 2. So, dear students, you have to remember this formula. I equal to h by 3 multiplied by y naught plus yn plus 4 times y1 plus y3 plus y5 till yn minus 1 plus 2 times y2 plus y4 plus y6 up to yn minus 2. Now, the second one is called Simpson's 3/8 rule or 3 by 8th rule. Here also same thing. Let I equal to integral from a to b f of x dx be the given integral to be evaluated. To use Simpson's 3/8 rule for evaluation of the value of I, the interval ab must be divided into n number of subintervals where n should be a multiple of 3. Again, students, you have to remember, to use Simpson's 3/8 rule, n should be a multiple of 3. And Simpson's 3/8 rule is given by I equal to 3h by 8, which is multiplied by y naught plus yn plus 3 times y1 plus y2 plus y4 plus y5 plus here next terms should be y7 plus y8, it continues till yn minus 1, plus 2 times y3 plus y6 plus y9, it continues till yn minus 3. Again, students, you have to remember this formula to work out the problems. Now the third one is Wedel's rule. Let I equal to integration from a to b f of x dx be the given integral to be evaluated. To use Wedel's rule for evaluation of the value of I, the same thing, interval a comma b should be divided into n number of subintervals, where n should be a multiple of 6. For n equal to 6, Wedel's rule is given by I equal to 3h by 10 multiplied by y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5 times y5 plus y6. You have to remember this formula for n equal to 6, that is Wedel's rule. Next, note, when we divide the interval ab into n equal parts, there will be n plus 1 values of x, that is x0, x1, x2 up to xn, and the corresponding values of y also n plus 1 in number. There are again n plus 1 number of values. These values are referred as ordinates. So we can conclude that if there are n plus 1 ordinates, then there must be n equal divisions. For example, in some problems it may have given as there are 7 ordinates. If there are 7 ordinates, dear students, then we have to take n as 6. If there are 9 ordinates, means then we have to take n value as 8. So if there are n plus 1 ordinate, there must be n equal divisions. You have to remember this. Now we will work out the problems. First problem, evaluate integral from 0 to 1 x divided by 1 plus x square multiplied by dx by using Wedel's rule, taking 6 equal subintervals, that is, we have to take n value as 6. Now solution. The first step is compare given equation with integral over ab, integration of a to b f of x dx. So when you compare this with this, we get f of x as equal to x divided by 1 plus x square, the lower limit a, which is 0 if you compare here, and the upper limit b is 1, and n is given as 6. Now first we have to calculate h value. H is given by the formula b minus a whole divided by n, that is 1 minus 0 by 6, which is 1 by 6. Now first we will find the values for x as below. This is very important. x0, which is equal to a, which is 0. Now x1 can be found by using the formula x1 equal to x0 plus h, which is 0 plus 1 by 6, which is 1 by 6. x2 is given by x1 plus h, which is 1 by 6 plus 1 by 6, which is equal to 2 by 6, which is equivalent to 1 by 3. Next we will find x3, which is given by x2 plus h, that is 1 by 3 plus 1 by 6, it comes out to be 1 by 2. x4, which is given by x3 plus h, 1 by 2 plus 1 by 6, which is 2 by 3. x5, which is given by x4h, that is 2 by 3 plus 1 by 6, which is 5 by 6. x6, which is x5 plus h, that is 5 by 6 plus 1 by 6, which is 6 by 6, which is equal to 1, which is the upper limit b. So we have to start with lower limit and we have to get upper limit. So students, here we have to start with lower limit x not equal to a equal to 0, and we have to get the upper limit, which is b, which is equal to 1. With h equal to 1 by 6, we get x6 as 1. Now we tabulate x and y values as follows. That is, we will calculate x and y values as below. X values are x naught is 0, x1 is 1 by 6, x2 is 1 by 3, x3 is 1 by 2, x4 is 2 by 3, x5 is 5 by 6, x6 is 1. And f of x, which is y value, x by 1 plus x square. When x is 0, we will get y value, that is y naught, as 0. When x1 is x is 1 by 6, we will get y1 as 0.1621. So we have to calculate y values corresponding to each of x values. And finally for x6, we get 1 by 1 plus 1, that is 1 by 2, which is 0.5. Now we have Wedel's rule for n equal to 6, I equal to 3h by 10 into y0 plus 5y1 plus 5 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. Now we substitute these values. H is 1 by 6, then y0 is 0, 5 times y1 0.1621 plus y2 is 0.3 plus 6 times y3 0.4 plus y4 is 0.4615, y5 is 0.4918 5 times plus y6. So if you calculate this value, we will get this I value as 0.3465. Dear students, these problems are very easy to solve. Now we work out one more problem. Second, evaluate integral 4 to 5.2 integral of log x to the base e dx from 4 to 5.2 by using Simpson's 3/8 rule, taking 7 ordinates. 7 ordinates means n is 6. Now the same procedure we have to follow. Compare given equation with integration from a to b f of x dx. What we get is f of x equal to log x to the base e. Limits are lower limit a, which is 4, b is 5.2, and n is 6. 7 ordinate is given, means n value is 6. Now we will calculate h value, which is b minus a by n. b is 5.2, a is 4 divided by 6, 1.2 by 6 is 0.2. Now the next step is we have to find the set of values of x. So we start with lower limit a, which is also equal to x naught, which is 4. Now x1 can be calculated by using the formula x naught plus h, which is 4 plus 0.2, 4.2. Now x2, previous value of x1 plus h, 4.4. x3, x2 plus h, 4.4 plus 0.2, 4.6. x4 as 4.8, we get x5 as 5, and x6 as 5.2, which is upper limit. These x values are very easy to get. You just add the value of h value to the previous values until we get the upper limit. Now we tabulate x and y values as follows. X values are 4, 4.2, 4.4, 4.6, 4.8, 5, 5.2, and corresponding y values, if you calculate, then we get these values. Y0 as 1.3863, y1 as 1.4351, etc. The last point y6 is 1.6488. Now Simpson's 3/8 rule is general formula is given by I equal to 3h by 8 y0 plus yn plus 3 times y1 plus y2 up to yn minus 1 plus 2 times y3 plus y6 plus y9 till etc. up to yn minus 3. Now for n equal to 6, The above formula reduces to 3h by 8 y naught, n is 6, y 6, plus, here double plus is there, it should be plus only, plus 3 times y1 plus y2 plus y4, y5, yn minus 1, 6 minus 1 is 5, it is already included. So here n is 6, so it is only 6 minus 3, y3 we have to include. Now, if you substitute y0, y1, y2, y3, y4, y5 and y6 value in this formula, what we get I value is 1.8278. So the value of I is integral is 1.8278. One more problem. By using Simpson's one-third rule, evaluate integration of e power minus x square dx by taking 6 strips. From here the limits are 0 to 0.6. 6 strips means n value is 6 here. So the same procedure we have to follow as we have followed in first two problems. Compare given equation with I equal to integral from a to b f of x dx. We get f of x as e power minus x square. Lower limit a, which is 0. Upper limit is b, which is 0.6. N is given as 6. So h will be b minus a whole divided by n. 0.6 minus 0 by 6, which is 0.1. So now we calculate x values. X naught is 0, x1 which is x naught plus h which is 0.1, x2 x1 plus h 0.2, x3 x2 plus h 0.2 plus 0.1 0.3. Similarly we get x4 as 0.4, x5 as 0.5 and x6 as 0.6, which is the upper limit b. Now we tabulate x and y values. For y equal to e power minus x square, when x is 0, y value we will get it as e power 0, which is 1. Similarly, when x is 0.1, y we get 0.9. So the values are listed here. So we have Simpson's one-third rule in general. I equal to h by 3 y0 plus yn plus 4 times y1 plus y3 plus y5 etc. up to yn minus 1 plus 2 times y2 plus y4 plus y6 etc. up to yn minus 2. So for n equal to 6, what we get is h by 3 times y0, n is 6, y6 plus 4 times, since n is 6, I will get here y5. So I have to write the formula up to y5, y1 plus y3 plus y5 here. And the last term, n is 6, so I will get 6 minus 2, which is 4. So I have to write these terms up to y4. So 2 times y2 plus y4. So when you substitute x and y values in this equation, what we get is I equal to 0.5334. So we will continue the problems in our next video. Thank you.